Hi and welcome to Type A Retirement. I'm Stu. What we're going to cover today is the build of a motorized router lift. Not just a motorized router lift, but one that's made with solid extruded aluminum. Very easy to work with materials. Readily available off of Amazon, and a router lift that you can build yourself for less money than what you'd pay for a commercial lift, and you get the bonus of having something that is motorized. So let's get started. So here on the table is essentially all the parts that we're going to need for the build. In addition to this, there's also obviously the router plate that will get mounted into the new tabletop when we do that. But there's vertical rails, horizontal rails, connectors that connect these pieces together. The screw drive with a NEMA 17 motor, coupler to couple the motor to the screw drive. These are the mounting pieces that will mount the lead screw to the lift. Guide rails, these are just linear guide rails, gives some stability on two other axes. Motor drive, this motor drive is a controller and driver all built in one, and obviously the cable, motor mount, and that's essentially it. That's everything that we need except for the router plate and the mount for the router, which we'll get into in a little bit. So we're going to start assembling the vertical rails to the horizontal rails. A little bit about this material. It's called 2020 aluminum, and this is the European style, which means that the end, it's not just a squared off rectangle for a T-slot. It's actually beveled on the inside. They call it a V-groove. Most of the materials that you'll find will be the European style. You can find some that are in units that you'd be more familiar with, maybe inches, quarter inch, that kind of thing. But this is a standard. It is widely available. You can find it in many different places and at many different price points. This is a 2020 aluminum extrusion, so it's 20 millimeters by 20 millimeters. We're going to use that throughout on this build. You'll see me using the 20 millimeters as a simple spacing. We're going to attach these parts together with an L bracket. The L bracket has a notch on one side that allows this to slide up and down in the groove. And so we're going to put the slide portion on the vertical so that we're able to control the height. And so let's just get busy putting these together. We're going to start with one rail and then do all the top rails, do these in pairs, and then connect the pairs together. Now, like I said, I like to use that 20 millimeters when I can as a story stick, and in this case it's a story stick to set the amount of space that I want down from the top for this first rail. There's nothing real magical about that. It's low enough that it'll be out of the way. Nothing will interfere with the top surface, and it's also high enough that I can still drive the router all the way up so that I can get at the nuts to change the bit. So let's use that. We'll put another L bracket on this side. Now, to make the assembly more repeatable, I am going to use a clamp. I'm going to fix the clamp across the width. What I am going to do is just keep making sure that that top surface is flush. And if I do that on all the pieces all the way around, these rails will be at the exact same height for all pieces. So that's about it. Then I just got to get the right bit, and I like to go in and just kind of snug them up just by hand, and then we'll tighten them. Now, my preference when we get to that tightening stage, I find that I get more repeatable results, on this application is to tighten the vertical sides first. And there's no reason not to go ahead and fully tighten this as you go along. Okay, there's one side. And we'll move on to this next one. Okay, so that's the first set of rails. The second set of rails, their position will be set by the distance of things like the linear slides and the screw drive. And so as we put this together, that position will float according to where we mount this. And that's perfectly okay. Everything is still going to be extremely accurate. It doesn't really matter with these parts exactly what height that it is, as long as you have enough room to get the lift that you need. What we're going to do is install the first bracket on two sides for the linear rails, the screw drive on one of the other sides. The way that we do that is with these screws and these T-nuts. The T-nuts, like I said earlier, will self-align. All that we have to do is install them on the little brackets, put it over the slot, and it will align in. And then when we tighten it up, it'll grab a hold of the rail. We line them up sideways, drop it down in, and then when we come back and we tighten this, that nut will twist in the V-groove, only in that tightening direction, and then it'll be installed. So we don't care too much about the position right now, just snug, ready to go. Same with the other one. We'll do the exact same thing. Okay, so there's the linear rails. They're installed. The outside of the bracket that holds the router will travel up and down on these rails, and their position will get set. You'll see when we get to the actual bracket, making that bracket out of the vinyl boards. The screw drive, that's a little bit different, and it will need to float and then align to that bracket because it is very particular on where it is and how straight it is. So we'll install one end of the screw drive, so it has the pillow block bearing installed, and we'll be doing exactly what we just did with the linear rails. Screws and nuts, drop them down in, snug them up. Okay, so now that we've got these installed, we can go ahead and set these other rails in place with the end blocks. So let's put this block on. And again, this is just a fixed block. And you can see from here how this all lines up and how it mounts. And now when we mount the router mount inside here, it will slide up and down very cleanly on these. And to ensure that, we're going to use these linear bearings. Now these linear bearings actually have ball bearings inside that slide up and down, in the balls or on the side on the different faces, but in a row, so it will slide up and down and the balls will roll as it's going and make this all very smooth. So that's all that it's doing back and forth. We'll be mounting this up against the guide plate in this piece in here with this block on the end. Now, again, as long as we've got enough distance for the amount of lift that we want, we don't care how this is positioned. Just for aesthetics, we're going to try to keep it so that it's right at the end, but it's not as critical as you'd think. So this is the overall frame assembly. put together, pretty much ready to go, ready for the next pieces. So we're going to go ahead and fabricate a router plate with center hole, some clearance, zero clearance inserts, and then mounting for the motor. When I was designing the system, I designed around a certain mounting plate, which when everything is put together, sits parallel with the back of this frame. So I need something that crosses the back of the frame for the mounting plate to mount on. And we'll make that. We're going to fabricate that on the laser engraver, and then final assembly, install the router, and off we'll go. All these pieces are going to be made out of 1/8" acrylic. The first thing that I'm going to work on is the mount for the stepper motor. You can see a port in the back of the box. That's for my shop vac, which is then vented outside. It has a HEPA filter in it, but it also does port to the outside, so all of this smoke that gets generated will end up going out there. So I'm going to close the cover and then route these pieces. Okay, so we just finished up the second motor mount for the stepper motor. This is what the panel looks like. It's got mounting holes that line up with the rails on both sides, and then the mounting holes for the motor. I'll show you how that goes together. So in addition to the plate that will span between the two rails, there's also spacer blocks that set the right height of the motor. Two more pieces of the same 1/8" acrylic that we're going to glue down onto here with the holes lined up. To line up the holes here, we're just going to use a couple of screws, and just to be on the safe side, I'm going to do one plate at a time. So now the spacer blocks are on here. We're going to put the motor mount on, and then mount the motor to the motor mount, and put the panel in and make sure that we can get everything in alignment. Okay, so it's mounted into place in these rails, into the coupler that then couples the lead screw to this block. So when the motor turns, it's going to turn the lead screw and move this block up and down. This is what the router mount is going to be riding on. And so far, everything, without too much adjustment, is pretty smooth and pretty much ready to go. We got to tap these holes. I've chosen number 6, an M6 tap. So that's very equivalent to a 1/4 inch. So you could do 1/4 20s, or you could do something smaller. The reason that I'm going as big as I am is that I want something with a robust head as well. The countersunk head up in the router plate that's going to be mounted in the table. Everything is going to be hanging on essentially those 4 locations, and I want that robust. So we will get started on that. I will take this lead screw off. The linear bearings are not such a big deal, but I don't want any little shavings or anything to end up in that lead screw. That's pretty easy. A couple of set screws to loosen and it'll come right off, and then that'll be out of the way. We'll tap these. We'll use the laser engraver to get the router plate done. I'm also going to use the laser engraver to create a routing template, so that we can use a pattern bit with the router to create this mount that this all goes into. And it's actually going to be 2 pieces of 3/4 inch material, so it'll be 1.5 inches thick that will surround the body of the router. Okay, well, we're done with the laser engraver. We made the back plate that mounts the stepper motor. We have an outline for the router mount that goes in here. we'll use this as a template to make the final version. And then we also routed two different plates. One with a smaller inside hole that allows us to use zero clearance inserts around the bits. The larger hole, these line up and give us something that we can bolt down through. We're going to countersink these holes. The zero clearance inserts go in. There's placements for screws if we want to add nuts onto that. This gives us a fairly rigid surface, something that we can hang by. Gives us about 3/4 of an inch all the way around that we're able to use as a lip in the router table to hold these pieces. Now on the mount, it wasn't all that important on the gluing of the two pieces together. This is much more important. The reason being is that we don't want any separate flex in the middle from the because that's where the insert's going to be, so we don't want that to be something that can become lower than the rest of the plate or higher. So we're going to go ahead and work on the glue up, and then we'll countersink the holes, get the threading done in the end of these rods, and then set up to route the router mount. Okay, so the assembly of all of this is complete. The top is on. We've got all the frame, everything put together. These are nice and centered. The screw drive is in the center, ready to go. So now it's just a matter of creating the mount for the router and then installing that. So let's get started. So I have the template mounted on the piece of vinyl that we're going to start with. A patterning bit in the router table. Some dust collection. It's going to get messy. I'm just going to accept that. And we'll just take a couple of passes at this, take it slow but sure, and hopefully get down to this rough shape very quickly. Okay, we got both pieces cut. As you can see, it's going to be about 1.5 inches thick. Placement for the lead screw block. The linear rail blocks will get bolted onto the side. We'll be able to take this end and squeeze the end together to get pressure onto the router. These have to be epoxied together. I'll use a 2-part epoxy, but right now I've got a lot of cleanup to do. I made quite a mess with this. So I think that's about all that I'll do tonight. So far, if you discount the filming, I probably got about, I don't know, 3.5 hours, 4 hours into this whole thing, including at this point getting the router mount done. So, you know, I think that we should be able to finish this up in another hour tomorrow, maybe an hour and a half. So 4, 5, 6 hours, pretty easy to put all of this together. So this cutout is so that we can draw these two halves together and apply pressure to the router. What I'm going to use is bolt with a threaded insert on the opposite side. I'm going to put 2 in, one at the top half and one at the bottom half, because this is two pieces. I think it'll give me a little bit more stability. One of the things that I didn't like about the prototype was just accessibility. Taking the router out took forever. This method of holding it in place will hopefully make that a whole lot easier. Have easy access to these bolts, be able to loosen it, drop the router out, take the router off for other jobs. Now, the first thing I want to do is create a hole from side to side that's in alignment. The easiest way is going to be with a hand drill, but because of these shelves over here, it requires that the bit is long enough that it can go through both pieces. We'll then drill out the holes to have a clearance for the bolt, but then also the proper size for the threaded insert. So now for the nuts, for the threaded inserts, I've got the appropriate size bit. And I'm going to drill these out, making sure that I don't go through to the other side. I don't want to create a weakness. I'm going to do this side. And that gives me the holes for the threaded inserts. Then I'm going to change bit clearance for the bolt. And do those. And as you can see, this is very easy material to work with. Going to clean up these holes and then get the threaded inserts installed. So to assemble the mount into the system, all that I'm going to do is I'm going to rest the mount on the lead screw block so that we're sure that that orientation is right. And then these other two blocks we're going to stick a single screw into, and then we'll adjust the mount so that it's parallel to the top surface. That's what's important.
So because the rails are parallel with the top surface, placing a steel rule across the router mount gives us an idea that whether or not we've achieved flatness for the mount itself. As we adjust things up and down, we're able to get the rule the same distance away from the side rails, and we can also position front to back and get the same measurement done, and then tighten everything down, and we should have a perpendicular router to that top surface.
After we get the router mounted, we'll go ahead and make sure everything is flat and level again. There is minor amounts of adjustment here, but it can also be done within the router itself. Now that we've got this close, when the router is in there, we can move it slightly, a couple of degrees. That will give us enough adjustability to get by any tolerance that we created with what we've got here. So now from the top of the chuck to where the router is going to be mounted, I just take a simple measurement, and then I'm going to adjust this so that the bottom is about where that is, and then I'll drop the router down in from this side. And then we're going to put the router in from this side. The way that this is going to mount is that these are the sides, this will be the back, this will be the front. The way that I've got my router table wired is for the cord to come out on this side, so I'm going to go ahead and orient it that way to start with. Take my metal band, get it into rough alignment here. So I took measurements, got everything flat and level. I'm going to go ahead and put the plate back on, and then I'll talk about the motor driver and what has to be done there. So the motor driver, this is a controller driver, and it's got a connection for power, which is just 12 volts that we're going to put in, and then a connector with 4 screw terminals for the actual drive to the motor. Now the motor comes with a cable with connectors on both ends. So we'll install the connector on the motor, but on this end we need to cut these wires, strip them back. I'm going to tin them, and then we'll use those as connections down into the driver controller. The 12 volt power, a simple adapter works pretty well. Power adapter off of the internet. I'll leave a link also for that. You just want to make sure that you get one that's rated high enough power to be able to drive the motor. Anything above a few amps is more than enough. So to hook up the motor driver, there's the cable with 2 connectors. One is a 6-pin and one was a 4-pin. I took the 4-pin connector and cut it off. And then we have these screw terminals. So there's only a slight confusion on the screw terminals, but overall it's pretty simple. If you look at the cable, which is a flat cable, it goes red, blue, green, black. In this connector, we're going to do red, blue, black, green. But other than that, it's pretty straightforward. You insert the wire. Now I've gone ahead and tinned the wires. Just took the soldering iron, ran a little bit of solder on it, and then trimmed it to length. Get that in there and tighten down the screws. And again, the last 2 are reversed from how they are in the flat cable, black and then green. For each of the motor drivers that are out there, there's a specific schematic that you can get that will tell you how to wire them up to the motor. And then what's nice is that this is a simple little connector, allows you to plug in. And so by getting an adapter, the one that I chose and that I'll link to actually has a very simple way to connect this all together. For now, I'm going to pull out the power cable from the existing bench to bring it over here. I've wired this up through my bench system. You can see the little LED turns on. Everything is up and running. So now on the motor controller, if you hold the button, the knob, and push it in and hold it, it'll start flashing. Now the function 1 is what we want to concentrate on, and by pressing the run stop button, it'll move to the parameter. We're going to set it at 2. Press it again to go back to the function, and then stop it. When we press one or the other button, it's going to move in that direction only until we stop pressing the button. As soon as we let it go, it'll stop. And that's what setting the parameter number 2 does. If we had left it at parameter 1, it would have continued to rotate whenever we hit a button. It would just a momentary. I'm going to set both of the rotations at 40 RPMs. That seemed to work pretty good for the prototype. Now let's hook it up and see if everything is working right. I'm going to go ahead and plug in the motor. And then pressing the button, it all does move. You can see the chuck coming up. Gets to a good height. Also retreats back down pretty smooth, easy. So now let's make sure that with a bit installed that it will drop down far enough. So we'll put in a nice long bit. We don't have to worry about tightening it. And then we'll go ahead and lower it. Make sure that we've got enough control to get that down to below the table. It makes it really nice to be able to put the bit down below and then just leave that bit right in the table. You can see that it's down more than low enough, well down below the table height, and we've actually got a little bit more reach beyond that. Now in another video, I'll install limit switches that will pick up the height of this, both in the top and in the bottom, and disconnect power. Right now, if you go too far, it just keeps on trying. And rather than chance damaging the motor, we'll just add some limit switches. And then my plan is to actually go ahead and automate this in the long term. Something that will sense bit height to where we can say, okay, that's flush, and then that we want to raise it a certain distance and have that happen all with numeric control. And again, with this knob, with whatever one that you're working with, you can change the speed so that it goes up and down faster or slower.
So these drawings give the dimensions that I used for this build. About the only thing that you'd have to worry about changing is maybe the hole diameter for the router that you choose to use. But everything else, these dimensions worked great.
So I hope that you enjoyed the video, maybe gave you some ideas on ways to motorize a router lift. This one fits my needs, but I will be adding some limit switches. That'll be in an upcoming video along with the creation of the fence for my router table. If you did enjoy it, please consider liking and subscribing to the channel, and I'll keep videos coming. Thanks.